Okay, so we're going to do 1.6, which is understanding integers. It's pretty much a review of all the integer operations. So if you know the stuff and you know it down pat, great, go to the practice and do them. So let's take a look at number one. It says here, now there's pretty good description of what's going on with number one. So let's take a look at it. Atoms contain protons, neutrons, and electrons. Each proton has a positive charge. Each electron has a negative charge. And neutrons have no charge at all. An atom, by definition, is neutral and has the same number of protons and electrons. An atom, so a neutral atom doesn't have any, has the same number of protons and electrons. An atom can gain or lose electrons and become a charged particle called an ion. A positive ion has more protons than electrons, while a negative ion has more electrons than protons. Use this information about atoms and ions to complete the charge from the protons and charge from the electron columns in the following table. Now, I tried looking at this, and I'm not sure what they really want us to put into these columns, but I know that there's a few of them, like this one, the sodium atom. It has the same number of protons, it's the same number of electrons, so charge from protons, I don't see any, as well as charge from electrons. I didn't see any of those. Now, this sodium ion has a 11 protons, 10 electrons, so it's going to have a pos of +1 here from the protons, while still nothing from the ions. Here it's all neutral. The next one, chlorine atom, is all neutral, so I'm going to put zero charge from electrons and protons. The next one, chloride, it has a zero charge from the protons, but it's got a +1 here for the electron. All right, so it's got one more electrons. And actually, you know, since it's a negative, well, I'm going to leave it as +1. Aluminum as a neutral, so 0, 0. And the aluminum ion is going to have a +3 for the protons and 0 from them. So I'm assuming that's what they wanted us to do to fill out that charge. It's not quite clear, but I'm okay with this. Number two, the abbreviation for an ion includes either a positive or negative exponent that represents the net charge. If the net charge of an ion is +1 or -1, so this should have been a negative up here in our chart. So this should have been a negative here up in our chart, -1. Only a positive or negative sign is shown. Since the 1 is implied, because the net charge of an atom is 0, no exponent is written. Explain how to determine the net charge, which is shown on the atom or ion symbol in the table above. Explain how to determine the net charge, which is shown on the atom. Well, they just told us what the net charge is. So for the sodium, well, it depends if it has a +1. Whatever has a plus is a net positive charge. While the negative sign is going to be a net negative charge. So again, I'm assuming that's what they wanted us to do there. Number three, an atom can become a charged ion only by gaining or losing electrons, not protons. An atom and an ion of the same element always have the same number of protons. Use the information to complete the following charge. Okay, so the hydrogen atom starts out with the hydrogen atom, has one proton, which means since there's a zero net charge, it has to have one electron. Hydrogen has a plus, so it's a plus one. So it has a plus one charge, so it has to have one more proton than an electron. Okay, oxygen should be neutral because there's no plus or minus there. So if it has 8 electrons, it has to have 8 protons, and the net charge is 0 because there's, again, no sign there. Let's see, oxygen ion has a 2 minus, so it should have a two more electrons than protons. So if it has the 8 protons here, it should have 10 electrons, which gives it a charge of 2, and since it's an electron, it's negative 2. Okay. Calcium atom has 20 protons. It's neutral, so the net charge is 0, so it has to have 20 electrons. So if it has a positive 2, the ion, calcium ion, that means it has to have 2 more protons. And I think it's stated up here, we only gain or lose electrons. So it's got to have the same number of protons, but for it to have a plus 2 means we're going to have to take 2 out of the electrons because we can only gain or lose electrons, which then would give this a plus 2 net charge. So a little confusing, but again, this course is all about reasoning out these word problems. Next page. Okay. Number 4. Let's see what they have up here as a little explanation. Negative numbers may seem abstract since they don't represent physical counts. However, they are naturally occurring situations in which we have less than 0, such as debt. Negative numbers allow us to describe such situations. All numbers were created to deal with issues that occur in life, whether we are dealing with debt or counting a set of objects. As you understand, work through the section, understand the difference between the sign and size of the number. Do you know that two negatives make a positive? Well, that's true when we're multiplying and dividing, but adding and subtraction, adding it does, and subtracting, not so much. You can have different situations. All right, number 4. Describe the kind of numbers you would use to answer the following questions. How many cars are in the parking lot? Well, you can't have negative cars in the parking lot. You can only have positive counts, a positive number in the parking lot. By the way, 0 is not negative, or is it positive? So it can be 0 or a positive number. B, what is the depth of the submarine relative to sea level if it is descending at a rate of 200? Descending, so it's going to be a negative number. Beth purchased a candy bar to share with her children and husband. How much will each person get? So each person is going to get some of the candy bar, so it's going to be a positive number. And Jake uses a spreadsheet to keep track of his finances. He lists all purchases and bills for the month, as well as any income. How much money does he have left? So he's going to be subtracting those numbers or adding a negative. So it's going to be negative. Historically, sets of numbers have invented help. Go ahead and read that. A negative number is less than 0. That's pretty important. Think of a number line. Okay. Negative number is less than 0. We indicate a negative number by, of course, putting a negative sign in front. Positive numbers have positive signs in front, but we never really write them. Okay. The size of the number, it's just, it's the distant, it's where it is on the number line. Okay. The size of the number is absolute value. Okay. Absolute value means the distance from 0. So let me explain this a little bit. Let's look at this. Let's look at a number line here. I'm going to go ahead and put a number line in. Okay, here's 0. Here's 1, 2, 3. Here's 1, 2, -3. Okay, now when we talk about absolute value, it's again, a good definition is it's distance from 0. So let's look at the location 3. The location +3 has a distance of 3 units. So +3, the absolute value is 3 units. So the absolute value of +3 is 3. Let's look at -3, the location -3. It's also 3 units from 0. So the absolute value of -3 is also 3. So anything that comes out of absolute value bars is a positive number. It's the absolute value, the distance from 0. Distance is always measured in positive numbers. Think of your geometry course. All right. Let's see, anything else here? -17, a lot of your elementary teachers taught you it's actually, when you're thinking of a negative number, it's the opposite. You're adding the opposite of the positive. So it depends on how you were taught. In the later sections here, I don't know if it's in this one, but when we do operations, I think it's the next section, you can always change a minus sign to a plus negative. Okay, so you're adding the opposite. It's a negative number. Okay, next page. Number 5. Now I know some of these are going to be like pretty basic math, but that's okay. We'll go through them. What is the opposite of -8? The opposite of -8 is going to be +8. We normally don't put the plus sign for positive. The absolute value of -11, again, anything that comes out, we want to drop the absolute values signs. It's 11 units from 0. So it's a positive 11. What is the sign of 24? It's positive. And of course, the size is just 24. The size is, they're getting really a little too basic there with having to explain the size. Read and simplify. Okay. The opposite of -6. Okay. Think of this as, again, if there's no number there, we know there's a -1 there. It's 1. And we're multiplying -6 by -1. And if you remember, a negative times a negative, and again, we'll get to it in the next section, is always a positive. So that's +6. Or you can read it like this. The opposite of -6 is +6. I like thinking of it as a multiplication problem. E, read and simplify the opposite of the absolute value of -6. Be careful, watch your order of operations here. Absolute values have priority over multiplication. So let's take the opposite of -6, which is +6, and then we have to take the opposite of that, which is -6. Or think of it like this. -1 times the absolute value of -6. So we have -1 times +6, which is -6. Either way. 6. Following examples do not use negative numbers, but each has a positive or negative meaning. Determine whether the meaning is positive or negative. If it's a negative, write the sign. Okay, below sea level, well, right there, the word below is going to tell you it's a negative number. Okay. $500 in black. If you go up here and read the directions, it does a lot of accounting work. If a number's in red, and you're going to be deducting, which is a negative. If it's in black, it's a positive. So this is going to be a positive 500. Number 7. The following situations contain negative numbers used in real life situations. Interpret what each one means. Okay, so when you see this, the -30 Fahrenheit, it's temperature, of course. We usually call it, well, this is 30 degrees. We want to write it out in the English language. We read it as 30 degrees below 0. So you got to watch how we interpret symbols here in real life situations. That's what you're doing here. B, a pole has a plus or minus 3% margin of error. Well, if you look at that 3% of margin of error, that means it's actually a range of 3%. So we're going to say here, the real percentage, say this is 50%, shows a pole of 50% has a plus or minus 3%. So the actual percentage has a range and if we go with 3 plus, that's 3 units, and 3 minus, that's another 3 units. So it has a range of 6 units, or in this case, 6%. Okay. Number 8, write a sentence to explain Lily Lake's enrollment. Okay, so this is a school district, and they have all kinds of different schools. And think of this as your number line here. So if we look at our number line, let's bring a line down here, and it looks to be at -17. And here's the highest one here on the bar graph. That's a +17. So this school district, so Stillwater District, and this is from 2013 to 2018. So it's going to have a range. District has a range of population from the years, let's say in between 2013 through 2018 of plus or minus 17. And the last page. Okay, the periodic table of elements provides helpful information about each element. The atomic number up in the left-hand corner is the number of protons included along with the atomic mass, which is a number at the bottom. The atomic mass is always rounded to the nearest whole number is equal to the number of protons. So these two protons plus the number of neutrons. Using this information in periodic table entry for fluorine, which can determine that fluorine has a total of 19 protons and neutrons. Since the atomic number is 9 and it has 19 neutrons and protons, we can figure out the how many neutrons it has because we just take the atomic mass and subtract the protons, and that tells us how many neutrons, which is 10. So let's do that for each one of these. Okay, for phosphorus, we have a total of 30, and that's going to equal the number of protons, which is 15, minus the number of neutrons. Plus the number of neutrons is going to equal 30. So the number of neutrons has to equal 15. I'm sorry, I didn't round this up. This is 31, so it has to be 16. There should be 31. Okay, total number of protons and neutrons, the atomic mass, 32. That's going to equal the number of protons plus the number of neutrons. So the number of neutrons has to be 16. Chlorine, round it down, 35 equals the number of protons plus the number of neutrons. So neutrons has to equal 18. So some just real life situations here that you're using plus and minus numbers. And that'll do it for the notes on 1.6. Go ahead and do the practice for 1.6. And please let me know if you have any questions.